Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 8 of a unit Oscillations. So let's begin with today's class. This is part 2 of simple pendulum. In the previous sessions we were discussing about the time period of the simple pendulum, as well as we have seen the certain variations that how that time period of the simple pendulum can be changed. So let's moving ahead with this. First we will discuss about the certain laws of simple pendulum. Let's have a look. First is the law of length. It says that the period of simple pendulum is directly proportional to the square root of its length, and if it is directly proportional to its square root of its length, then t time period of the simple pendulum is directly proportional to the root of L. That means if L is increases, time period increases. If length is decreases, the time period decreases. We have seen this. We have seen this in the previous class as well. That now at this point of time we just understand that okay, this is the law as well. Second, it's a law of acceleration due to gravity. It says that T is inversely proportional. T is inversely proportional to the root of G. It means the period of simple pendulum. The period of simple pendulum is inversely proportional to the square root of its g. That means if g increases, this t decreases. If g decreases, then this t will increases. I hope this is clear. Next, it is the law. Next is the law of mass. It says that the period of simple pendulum does not depend on its mass. It is not depending on the mass. This is the law of mass. And next, it's a law of isochronism. When we say it's a law of isochronism, it means the period of simple pendulum, does not depend upon its amplitude. This is law of isochronism. I hope this is clear. Is it clear? So these are the four laws with which simple pendulum deal with. First is the law of length, that square root of the length is directly proportional to the time period. Second is the law of acceleration due to gravity, that acceleration due to gravity is inversely proportional to the time. Again, it's a square root of acceleration due to gravity, inversely proportional to the time period. Next, law of mass and law of isochronism, that mass and amplitude does not have any effect on the time period of the simple pendulum. So this all are the four laws. We have already done their questions. Now let's discuss a one very specific pendulum, that is what we call as a seconds pendulum, and we will try to find out the length of the seconds pendulum. So basically a seconds pendulum, it is a pendulum having time period of 2 seconds. It's a pendulum having time period of 2 seconds is known as seconds pendulum. So this is the seconds pendulum. It is a pendulum having time period of 2 seconds. This is what we known as seconds pendulum. So we have the relation, that is t is equals to 2 pi root of L by G, and for seconds pendulum this time period is equals to 2 seconds as per the definition. So if I put up the value, this is equals to time period, it's a 2, this is equals to 2 pi root of L by G, and this 2 has been cancelled out. So I have been left with this 1 is equals to pi under root of L by G, and from this L is equals to G by pi square. If I solve this, that let's suppose approximately pi square is equals to 10, approximate, then this length equals to 10 by 10, approximately it's a 1 meter, or if I say an exact value, then this L would be around 95 to 99 centimeter. Yes, this length of the seconds pendulum, because it varies from case to case. Whatever the options you were given, you need to choose it. So this is the length of the seconds pendulum. Please keep this in mind. And one more very important thing is its time period. That time period of seconds pendulum is 2 seconds, because when we listen it's a seconds pendulum, what our mind generally thinks that it is the pendulum having a time period of 1 second, and there is a chances to get a mistake. So please do this understood and keep this in mind that seconds pendulum is having length approximately 1 meter and time period it would be equals to 2 seconds. Now let's look at the certain quick questions. Length L of a seconds pendulum is the length of the second pendulum. Yes, the situation was something like this. This is T is equals to 2 pi root of L by G, and if it is such, then it would be given as T square is equals to 4 pi square L by G. And this time period, as we know that time period is 2 seconds, so it's a 4 is equals to 4 pi square multiplied by L by G. This has gone, and this L is equals to G by pi square meter. I hope this is clear. This is the length. This is the length of the seconds pendulum. I hope this is clear. Is it? Great. Let's look at this question. It's a second question. The period of simple pendulum. The period of simple pendulum does not depend on. Yes, the period of second simple pendulum does not depend on the amplitude, does not depend on the mass, but it depends on the length. It's a T directly proportional to the root of L. So this is the correct answer. It does not depend on the amplitude as well as it does not depend on the mass. Next, the simple the period of simple pendulum is directly proportional to the square root of its length. With acceleration due to gravity, it is inversely proportional to this. It's a T inversely proportional to the root of G and T directly proportional to the root of L. So this is the correct answer. I hope this is clear. Is it clear? Great. So please be ready with your pen and paper and do our questions with me. Let's begin. Let's suppose the question is, if seconds pendulum has been taken to the moon, find out its time period. This is the requirement. How will we do this? So first thing is that if it is a seconds pendulum, that means its a time period on the earth will be equals to 2 seconds. So its a time period on the earth will be equals to 2 seconds. What I have been asked? I have been asked to find out the time period on the moon. What actually varies? If you shift your pendulum to the moon, length does not changes. So length on the earth and length on the moon would be the same. Only the G will changes. And as we know, the acceleration due to gravity on the moon, it's 1/6 of the acceleration due to gravity on the earth. So this is Gm by Ge, that is equals to 1 by 6. I hope this is clear. Is it clear? Is it? Are you sure? Any doubts? No? Great. So let's work for it. It's a T on the moon divide by T on the earth, that is equals to length would be the same, and that has been cancelled out. So I have been left, it's a Gm to the Ge. It's so this is equals to Gm by Ge, that is equals to Gm is equals to Ge by 6, and Ge is equals to 6 Gm divide by Gm. So this has gone, and I have been left with that it's a Tm is to Te, that is equals to root of 6. So this is root 6 into time period on the earth. It is 2 seconds. So this is 2 root 6 seconds. This is the time period of seconds pendulum on the moon. I hope this is clear. Is it? Is it clear? Any doubts? Is there anything? Is there? No? Are you sure? Can we move ahead? Yes? Great. Now let's see the variation in time period of simple pendulum due to change in its length. Mostly the variation that we have learned up till now is the change in the g, whether it would be an accelerated motion or whether it would be an accelerated motion in downward direction or upward direction, or let's say it was the cases where acceleration is in horizontal direction and everything. Yes, so they all were the variations in the g. Now what we were trying to change the length, and we will look at the cases that how this can be achieved. So first, in variation in the length, we will change the length. Change in length, it is the case of change in length due to change in temperature. So we want to learn this. It's a f if length is going to be changed. If length is going to be changed, what due to change in the temperature, what would be their effect? We understand in the thermal properties of matter that if we change the temperature, then the length will changes, and this length will change. It's a delta L is equals to alpha into L into delta theta, and from this it's a delta theta. From this it's a delta L by L, it's equals to alpha into delta theta. So we have this relation that T is equals to 2 pi root of L by G, and from this it's a T square is equals to 4 pi square into L by G. So situation is 2 into delta T by T. This is equals to, let's suppose only the length is going to change and no change in the G. So this is delta T by T is equals to, or I should say 2 delta T by T, it's a delta L by L, and it's a delta T by T, which is equals to 1 by 2 into delta L by L. So as delta L by L is equals to alpha into delta theta, as we have seen in the last slide, it's a delta T by T, that should be is equals to 1 by 2 into alpha into delta theta. I hope this is clear. So this is the change in the time period due to change in the temperature. I hope this is clear. Is it? Great. Let's have one of the question based on this. If simple pendulum clock can give correct time at 30 degrees Celsius has been shifted to room at 40 degrees Celsius. Find out change in time per day. They have mentioned that alpha of the pendulum, that alpha of the material from which pendulum has been designed, is, let's say it's a 2 into 10 to the power minus of 5. It's a Kelvin inverse. So this is the value of the alpha, and they have given the rest amount of the data that they are working at 30 degrees Celsius absolutely fine, and that clock has been changed to new room, and that is at 40 degrees Celsius. So in this situation, delta theta which is equals to 40 degrees Celsius, minus 30 degrees Celsius, which is equals to 10 degrees Celsius. This is delta theta, and alpha of the pendulum clock has been given. It's a 2 into 10 to the power minus of 5. So from this, it is just the delta t by t, which is equals to half into alpha into delta theta, which is equals to 10. So this is equals to 1 by 2 into alpha, that is equals to 2 into 10 to the power minus of 5 into 10. So this has gone, and I have been left with the delta t by t, which is equals to 10 to the power minus of 4. So this delta t, a change in time, would be equals to t into 10 to the power minus of 5. They have asked me for the per day. That means it's a 24 hours multiplied by 60 minutes multiplied by 60 seconds into 10 to the power minus of 4 seconds. Now you can calculate it very easily. I hope this is clear. Yes. So can you do this kind of questions? Can you understand the situation? Are you sure? Are you sure? Any doubts? Is there anything? Is there anything? Are you sure? Great. So this is one of the variation. This is one of the variation due to change in the length. Now let's look at the second variation in the length, that this is due to shifting of center of mass of bob. Let's understood this with one of the question. This is the pendulum, and when we say that this is the time period of the pendulum, it's a t is equals to 2 pi root of L by G. We used to calculate length as from the point of suspension to the center of gravity or center of mass of the bob. So this would be the situation. Yes. Now let's suppose if we have taken a hollow sphere and that sphere has been filled with water. So this is the situation. Yes, this is this hollow sphere, and this sphere has been filled with the water. Yes, and it is having hole over here. That they said that if the sphere is having a hole at its bottom, find out variations in its time period. How will you do this? They said they have made a hole at the bottom, and if hole has been punched at the bottom, then what would be its time period? How shall we do this? What could be done? What do you think? What do you think? What could be done? So this is simply the situation that this is the bob, and initially it has been filled with water, and in this situation, let's say this is the center of gravity because it has been filled with the water. So let's say this is the length, and the time period of the given, its time period at this given instant, it's a t is equals to 2 pi root of L by G. Now after some time passes, this water is about to being drained out, and let's suppose the situation is like this, that only this amount of water has been left. So as you can see this, the upper part is the empty, and the lower part is having water. So initially the center of gravity was here, and now center of gravity would be here. So now the length of the pendulum should be considered like this. I hope this you understand this. Now after certain, let's call this as an L1. Then this is T is equals to 2 pi root of L1 divided by G. Now again after again certain instant of time, the situation occurs like this, that it is something like this, and it is completely hollow. Again, now if it is completely hollow, again it is going to regain its length as the previous one. Then this is equals to L, and now time period, it's a 2 pi root of L by G. So in this kind of situation, that initially it was length L, finally it was length L, and then it is length L1. So it is first increases as water starts to draining out, because center of mass of system starts moving downwards, and so length of pendulum increases. Once it is completely empty, it will again restore its center of mass at center of the bob. I hope you understand this. Yes, this is very logical aspect of change in the length, because every time it is not possible to change the length, you just cut down the string and a new length has been given. No, this is not the case. This is the logical aspect, and I like this question. Yes, because at our very first attempt, or at a very first sight, we could not identify that if water is being drained out, what is the effect? What is the effect on the time period? Because previously we have discussed that it does not have any dependency on its mass. Even certain students may consider it that as this water has been drained out, a mass of the bob has been changed, because as water is leaving the surface, and so that there could be a change in the time period. But mass, or I should say time period, is exactly independent of the mass, so it does not have any effect of mass too. Yes, so please understand this principle very carefully, and let's have one more question based on this principle. Let's suppose the question says that, have you seen the swing? Yes, have you enjoyed it in your childhood? Let's have a look. Initially you were sitting on the swing. Yes, you were sitting on the swing, and your time period was T. Then you feeling bored that this is not having fun, and you just stand up, and now your time period is T dash. I hope this is clear. So what I want that comment on time periods when child was sitting and then he was standing on the swing. So when we say comment, what I mean or what I want is that you need to tell me that the time period increases or time period decreases or something like that stuff. How will you do this? Think what is coming in your mind. Think it nicely. Yes, some of you might get an idea that initially when child was sitting, let's say this is the center of gravity of his body and this is the length from where it was hanging. Now center of gravity has been shifted to this and this is the length dash. So the situation is when child was standing on the swing, time period decreases, time period decreases, and when he was sitting, time period will be more. Yes, so I hope you are comfortable with this kind of questions. Are you? That can be done. Can it be? Are you sure? Do you have any doubts? Do you? Do you have any doubts up till now? No? Great. So now let's discuss the one special kind of pendulums. That is what we call as the physical pendulum. It's a physical pendulum. Now what physical pendulum is, it is the situation in which, let's suppose this is the rigid support, and with this rigid support we have hanged up one rod, and this is the point of suspension of this rod. So if I displace this rod from its initial position to this, then this will having oscillating motion like this. I hope this is clear. So a time period of physical pendulum can be given as T is equals to 2 pi root of I divided by mgt, where I is the moment of inertia. I is the moment of inertia of a rigid body, and d is the distance between point of suspension. It's a distance between point of suspension to the center of mass of body. Yes, it's a moment of inertia at the point of suspension. Please write this down. Please note this. Have you done it? Have you? Are you sure? So are you ready for the questions based on this? Are you ready? Are you? Great. Let's have a look. That this is the road. This road is having mass and length L. It is having hinged up. It is having suspended at the topmost position of the road, and they ask us find out time period of road. So the relation is, it is just the t, which is equals to 2 pi root of I by mgt. So let's just find out the I. That is that moment of inertia of a rod when it has been rotated from its end. That will be given as I is equals to ml square by 3, and center of mass of the road could be at the center. So this is the distance which is equals to L by 2. So this D which is equals to L by 2. I hope this is clear. So from this it is just the T is equals to 2 pi root of I by mgt, and this is equals to ml square by 3 multiplied by m into g into d, which is equals to L by 2. So if this has gone, this has gone, and this has gone, this has gone, so this is equals to 2 pi root of, this is 2, this is L, it's a 2L by 3g. This is the time period. This is equals to 2 pi t is equals to 2 pi root of 2L by 3g seconds. I hope this is clear. Does it clear? Do you have any doubts? Do you have any doubts up till now? No? Great. Let's have one more question. Let's suppose this road is having mass m, length 12, and it has been hinged at here, and this distance is L by 2. Yes. So the question again same, find out time period. So the formula for time period in this situation is T is equals to 2 pi root of I by m into g into d, and I is the moment of inertia at the point of suspension. So how will I find out? How will I find out the moment of inertia I? Because this is not at the end. This is not even at the center of mass. So what I need to do? Here the center of mass would be there, and this is at distance L by 2 because this total length is 2L. So this remaining is the L, and the upper one would be the L. And this point of suspension is at distance L by 2 from the center of mass. So what I need to do is I need to first find out this axis and this axis are parallel to each other, and so that I can apply a parallel axis theorem. Now what parallel axis theorem is said, it's an I required would be equals to I center of mass plus m into x square, and if such is the situation, then I center of mass could be written as ml square by 12, but I should write here m into L dash because this L, it is not an L because it is 2L in reality, plus m into x square, and this is equals to L by 2 whole square. So if such is the situation, then this I could be written as m by 12 multiplied by L dash. This L dash is the 2L, and which is equals to 4L square plus m into L by 2 whole square, which is equals to ml square by 4. So this is 4ml square by 12 plus ml square by 4. So this is just ml square by 3. So this is 7 by 12 m into L square. This is the just the moment of inertia. Let's find it out the D as well. That's why we can put it into the formula. That's D would be equals to L by 2. So if such is the situation, let's find out the time period. This T could be given as 2 pi root of I divided by mgt. Then this could be given as 2 pi root of I. This I is the 7 by 12 into ml square divided by m into g into d, and this d will be equals to L by 2. So this is 2, this is 6, this has gone, this has gone, and this has gone. So I have been left with the 2 pi root of, this is equals to 7 by 6 into L by g. This is the time period. I hope this is clear. It's a 2 pi under root of 7 by 6 multiplied by L by g seconds. I hope this is clear. Was it clear? Was it? Are you sure? Are you? Do you have any doubts? Do you have any doubts in this? Is there anything? Is there? No? Great. So this is the time period. This is the time period. Is it clear? Are you sure? Great. Shall we do the next question? Are you ready? Let's have a look. Give me the moment. Yes, the question. Let's suppose this is the disk having mass m and the radius. This is the point of suspension. It is at the uppermost position, and this is radius r. Yes. So they say it, find out time period. Find out time period of the given system. How will you do this? How will you do this? You need to find out the time period of the system. So the master formula is T is equals to 2 pi root of I divided by mgt. And when such is the situation, let's first find out the moment of inertia I. This is disk. When we rotate it from the center, this is equals to ICOM plus m into x square. Yes, so ICOM, it's an mr square by 2 plus this is mr square again. So this is equals to 3 by 2 mr square. This is I, and this d would be equals to r. So from this, let's put up this data into the formula, which is equals to 2 pi root of I by mgt. I, it's a 3 by 2 mr square divide by m into g into r. This has gone, this has gone, and this is equals to 2 pi root of 3r by 2g seconds. Correct. Are you done with this? Are you? What was your answer? What was it? What was your answer? Was it same? Great. So I hope you are comfortable with this, and this can be done very easily, that to find out the time period of physical pendulums. As we were discussing physical pendulums, let's discuss a special cases. Actually, this is not the case of the physical pendulum, but it has been associated with rigid body itself. So I I feel, let us take this here only, that this was the spring, and with the spring we have attached one of the sphere, and this sphere is having mass m, the sphere is having radius r, and the spring is having a spring constant k. And as the sphere starts rolling, please, it's a rolling, it's a rotational plus translational, it will perform SHM of lower amplitudes. Then time period of this situation could be given as this is equals to 2 pi root of, this is 2 pi root of m plus I by r square divided by k. This is the time period of the sphere or any object that can roll, but only spheres or ring or cylinder, only this spherical objects can roll. Other objects does not have an capability to roll. I hope you understand this. Do you understand this? Do you? Are you sure? Do you understand this completely? Yes? No? Yes? Great. So, can we have one of the questions based on this? Can we? Great. Let's work on it. The question says that we have a spring that has been attached at one of the end, and the other end it's let's say This is the hollow sphere having mass m, radius r, and if hollow sphere if hollow sphere starts rolling and performs SHM, find its time period. Do it yourself. You are having a time of 30 seconds. Please do it quickly. Yes, have you done it? Have you done it? No? Let me help you. This time period could be given as t is equals to 2 pi under root of m plus I by r square divided by k, and this will equals to 2 pi root of m plus I, it's a 2 by 3 mr square divided by r square divided by k. So this has gone, and this is m plus 2 by 3m. This is simply the root of 2 by 3 plus 1. It's a 5 by 3m divided by k. So this is equals to 2 pi root of 5m by 3k. I hope this is clear. Is it clear? Is it? Are you sure? Can you do this? Can you? Are you sure? Great. Shall I add something to this? Shall I? Let's have a look. The question says, if in the previous question hollow sphere is filled with water of mass small m, find out its time period. How will you do this? That this was the hollow sphere. Let me draw it again. That this was the situation, this was the spring, and with this spring one sphere has been attached, and now this sphere is being filled. Now the sphere is being filled with mass m, and this is going to oscillate. I need to find out the time period of this. So basically the master formula, what formula we have written, is t is equals to 2 pi root of m plus I by r square divided by k. This mass is of the sphere only. It's a mass m, radius r, spring stiffness k, and everything. But now the sphere is not alone. The sphere has been filled with one more mass, and that is what we call as a small m. Yes, it has been filled with water of mass m. So my formula would be changed by, this is t is equals to 2 pi root of, basically it's an m1 plus m2 plus m3 plus I by r square divided by k. Yes, it could be any masses that are going to added. You are just simply add them. So in this situation, it should be t is equals to 2 pi root of mass of the water plus mass of the sphere plus I by r square, that is of sphere itself, divided by k. So this will be 2 pi root of mass of the water, it's a small m, plus mass of the sphere, it was m, plus I by r square that we have already done, and that is equals to 2 by 3 of m divided by k. So this is equals to 2 pi root of, it's an m plus, sorry, It's a small m. It's a small m plus 2 by 3m, which is equals to 5 by 3m divide by k. And so this is equals to t is equals to 2 pi root of this is 3m plus 5m divided by k. This is the time period. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Now, do you have any doubts over this? Is there anything? Do you have any doubts for this? Are you sure? Are you sure? Any doubts? Is there anything? No? Great. Let's discuss one more category of pendulums. I hope you enjoy this. Yes? Great. How fun. So let's discuss the one more category, that is the simple pendulum. That is the simple pendulum of length comparable to the radius of Earth. So if length of the pendulum is very high, and that is comparable to the radius of the Earth, this is what we call as the simple pendulums having very large lengths. We need to find out the time period. Then time period of this could be given as t is equals to 2 pi under root of 1 divided by g into bracket 1 by l plus 1 by re, while l here is the length of pendulum and re here it is just the radius of Earth. Yes, this all are the cases of the pendulums that has not written by NCERT textbooks, and that is, you should not worry the about the theories that can be asked, that how this formula has been arrived and all that stuff. Yes, so I have not covered it. Probably your schools has covered the derivations of this. If they have covered with this, it's very good. If they have not covered with this, please don't worry and don't bother about it, because this all are the formulas that has not been written by the NCERT textbooks, and so that subjective exam, this is not should be covered in the subjective examinations. Yes, or or you should not worry about that, and you should focus only on the applications based on this kind of pendulums. I hope this is clear. So have you noted this? Have you noted this formula? It's a t is equals to 2 pi under root of 1 divided by, it's a 1 divided by g into bracket 1 by l plus 1 by re. Now let's suppose in a first case, when length of the pendulum when length of pendulum is very large, that is, let's say if L is much greater than RE, then what will be the situation? The standard formula is, that is, T is equals to 2 pi root of 1 divided by G into bracket 1 by L plus 1 by RE, and as I have condition which is L much greater than RE, that means 1 by L is much less than 1 by RE. I hope you understand this. And as this is the situation, this time period T could be written as 2 pi root of 1 divided by G into bracket, as this is very less, let's ignore it, it's 1 by RE. So this is equals to 2 pi root of RE by G. When this is 2 pi under root of RE by G, this is of 84.6 minutes. that it means the longest pendulum on the earth, the longest pendulum of the earth can have a time period of 84.6 minutes. Or even this could be considered and this could be assumed that the maximum possible time period of a pendulum that do exist on an earth can have time period of 84.6 minutes, and it could not be greater than that. This is the time period of simple pendulum, which is equals to 84.6 minutes. I hope this is clear. Is it clear? Is it? Great. Let's discuss the second case, that in the case 2, when when radius of the earth when radius of the earth is very large. If this is the case, when radius of the earth is very large, that means if r is much greater than l, then the situation is r is much greater than l. That means 1 by r is less than or much less than l. So my standard relation is t is equals to 2 pi under root of 1 by g into bracket 1 by l plus 1 by re, and this will give me a 2 pi root of, as this radius of the earth is very low, very less. So this is equals to t is equals to 2 pi under root of l by g. Yes, as 1 by r tends to 0. This is the second case. And let's discuss one more case. Let's discuss one more case in which if length of pendulum is equals to radius of earth. If this is the case, then according to the formula it is t equals to 2 pi under root of 1 divided by g into bracket 1 by l plus 1 by re. And as we understand that it's an l is equals to re, so from this it's a t which is equals to 2 pi root of 1 divided by g into bracket 1 by l plus 1 by re. So this could be given as t is equals to 2 pi root of 1 divided by g into bracket 1 by re plus 1 by re. So this is equals to 2 pi root of 1 by g into bracket 1 by re plus 1 by re. It's a 2 by re, or this could be given as 2 pi root of re by 2 into g. This is the time period. I hope this is clear. Is that clear? Is it? So this is the time period. This is the time period of the simple pendulum when length is very large and they have different kind of variations with the time periods. I hope this is clear. Is it? Is it clear? Are you sure? Can we do this? Can we do this? A same pendulum can be asked with certain questions. That, let's suppose, this is generally what we call as the tunneling. Generally we call this as a tunneling of earth, and the situation will be that, let me redraw. This is the earth, this is its center, and we have developed one of the tunnel over here, and let's say this is here we have one of the object, and if this object starts performing SHM, find out its time period. This is the question. So if this starts performing SHM, if this starts performing SHM, what we understood is that this is the case when length of the pendulum is much greater than RE. And if length of the pendulum is much greater than RE, then this could be given as this T is equals to 2 pi root of RE by G. Yes, that we have learned in the previous slides. And if this time period T, which is equals to 2 pi under root of RE by G, then this could be given as this is equals to 84.6 minutes. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Yes. I would like to mention one more thing about this, that this tunneling does not impact on the time period of oscillations. Yes, this tunneling does not have any impact. This tunneling does not have any impact on the time period of the oscillations. So in this situation, if it is something like this, that this is the pendulum and this is the tunnel and this oscillates, then this time period is 2 pi root of RE by G. And let's say if this is the situation where this, let me read through. This is the situation where this is the earth and this is the center, and you have developed a tunnel at one of the chord, and this is the situation that it will oscillate from this to this, then even in this situation the time period would be equals to 2 pi root of RE by G, because all this are based on L is much greater than RE. Are you, I hope you understand this very well, that this all are the based on the single case, and this single case is that this T should be equals to 2 pi root of RE by G. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you? Great. Now let's discuss one more category of oscillations. It's oscillations of liquid in U tube. It's a U-shaped tube. So the situation would be something like this. This is the level, and let's say this is the U-shaped tube. And in this a liquid has been filled, something like this. This is the angle alpha, this is the angle beta. Suppose you have been asked to find time period for liquid that oscillates in U-shaped tube. So for this, it's a T is equals to 2 pi root of L divided by G into bracket sine alpha plus sine beta. This is the time period where L is the total length of liquid column. This is the total length of the liquid column, and the time period of this could be given as this is equals to 2 pi under root of L in divide by G into bracket sine alpha plus sine beta. I hope this is clear. Is it clear? Is it? Are you sure? Do you understand this completely? Great. So let's have different variations of this question. Suppose we have given something like this, that this is the tube. One moment. It has been filled something like this. This angle is 30 degree, and they said find out time period of liquid. So my master formula, it's a T is equals to 2 pi under root of L divided by G into bracket sine of alpha plus sine of beta. And as we understood that this is 90 degree, as this is 90 degree, this is 30 degree, so this could be given as 2 pi root of L by G into bracket sine of 90 degree plus sine of 30 degree. So if I solve this, this is T, which is equals to 2 pi root of L divided by G into bracket sine 90, it's a 1, sine 30 degree, it's a half. So this is 2 pi root of L divided by G into 1 plus half, it's a 3 by 2, so this is 3. This is 2 pi root of 2L by 3G seconds. This is the time period. I hope this is clear. Is it clear? Is it? Are you sure? Great. Let's have one more question based on same concept. Suppose the data is something like this. Yes, this is the U-shaped tube they have used, and now it has been filled with the liquid. Yes, this is the height h. So in this situation, it's a T is equals to 2 pi root of L into bracket G into bracket sine alpha plus sine beta, and this is 90 degree, even this is 90 degree, so this could be given as 2 pi under root of L divided by G into bracket sine 90 plus sine 90, it's a 1 plus 1, and from this is T is equals to 2 pi root of L divided by 2G. This is the situation. Now if we neglect this horizontal part, this section, if we neglect the horizontal section, then this L is equals to 2h, and from this it's a T which is equals to 2 pi root of 2h by 2g. This 2 has gone, and I have been left with 2 pi root of h by g seconds. This is the time period. I hope this is clear. Is it clear? Is it? Are you sure? Great. So let's wind up the session over here. This was all about the simple pendulums. Yes, it is having a large amount of variations when we deal with the simple pendulum. So when and when we attempt questions based on the simple pendulum, please be very careful, because it is having a large amount of variations that can be done with the simple pendulum. So what you need to remember is that when and when we deal with the spring block system, we are having only two options. Either we can change mass, either we can change the K. We don't have any options other than that when we deal with the spring and block system. But with simple pendulum we have large amount of variation, so please be very careful while doing this kind of questions. And this all questions and this all relations can be remembered only when you will do a good amount of practice of very good questions. So please do as many questions as possible, because only that can make us to get questions of oscillations to be solved. Thank you. Have a good day. Take care.